If you want to truly understand how modern technology works, the internet hands you knowledge in shattered fragments. A little Python, a little machine learning, some cloud infrastructure, and noise about AI agents. You find yourself staring at over 100 different sources, textbooks, and documentation pages. They often use a language that makes outsiders feel excluded from the conversation. Instead of separate planets floating in space, these topics reside in the same house. They are connected rooms that share a single foundation. This chaos can be organized into a walkable path. We can transform the scattered noise into a sequence that anyone can navigate. Knowledge only becomes frightening when it arrives without structure. Providing that structure is the requirement for entering the technical world. To navigate this path, we use first principles thinking. Aristotle practiced this by stripping away the terminology to identify the core human problem a technology solves before naming the tool itself. Richard Feynman used this same logic to manage complexity. He broke systems down to their fundamental truths to ensure he actually understood how they functioned. Take cloud computing. This is simply rented computing power, sitting in a physical building elsewhere, connected to your laptop. Cybersecurity functions as guardrails around that physical building. It protects human value, ensuring only those with permission can access the resources inside. When you name the human need behind the technical word, the jargon loses its power over the conversation. Every major technical field connects through a logical sequence. It begins with data science, the disciplined method of gathering evidence to understand reality. That evidence feeds machine learning, a reasoning engine that sifts through data for mathematical patterns. Cloud and DevOps provide the structured place to run this engine in the real world. Finally, Python acts as the connector, automating the links between these separate steps. These fragmented topics actually form a single, interconnected supply chain of logic. Artificial intelligence is a mechanical system built to learn patterns. Its architecture draws from deep neural networks pioneered by researchers like Geoffrey Hinton. As Yoshua Bengio has demonstrated, these models rely on data and mathematical representations. They lack human-like intuition or consciousness. An agentic system is a capable worker inside a predefined workflow, designed for controlled action rather than autonomous thought. Turning a model into an operational agent requires specific constraints: memory for state, tools for tasks, and hard boundaries to prevent errors. Meaning always comes before the technical definition. An AI system is only as effective as the specific human constraints designed around it. The top of this technical learning ladder is human judgment. Advanced technology creates a greater need for human thinking. Higher speed requires more responsible decisions. We must build the mind before we build the machine. The true hero of any system is the workflow. Intelligence lives in the human review and the verification that happens before a system acts. This collection of over 100 sources represents a series of steps. You can climb them layer by layer. Understanding these connections brings you inside the technical world. When the path is visible, clarity replaces the noise, and judgment replaces the fear.